All right, so it's working. All right, so guys, today we're going to be looking at this theorem called the triangle proportionality theorem, and it goes right along with what we've been discussing with uh, triangle similarity. But there's a special relationship here. Now, to get started with this, before I start showing you the actual theorem, what I want to do is just kind of recap what we've been doing. So I'm actually looking at your quiz that you took the other day. So this particular um, problem, make sure I'm not in the way of it here. So if I was going to test this for similarity, I could take, well, there's actually a couple of ways I could do this, but the way that I've showed you is like, okay, so I have this little bitty triangle. Well, can't do it with a eraser, can I? This little bitty triangle's side is a 32. So I could say 32 over the big side, which is 42, and then likewise the GN right here, which is 40. I could set it over the 12.5, and I could go and cross product and determine if these sides are indeed in proportion to each other. So, but the thing I really want to focus in on right at this point is that the process by which I'm setting these up, we're going to use that same process on this triangle proportionality theorem, just to at least get the idea. But I'm going to show you that I'm going to show you with this theorem once you understand the components of it, that you can actually do this a little bit quicker. So let's take a look at number 1 here. If we followed the same model that I did with the previous problem, I would look at this triangle, and I'd say, okay, I could say the little side right here, 15, over the whole side, which would be x plus 15. So I'm still following that same model there. So right here, 12 over 14 plus 12, which is 26. Okay, so if you go through and you do your cross product, so 15 times 26 would be 390. Then the 12 times the x plus 15. So you got 12x plus, 12 times 15 is 180. So 390 minus 180, that's 210. By 12, so that divided by 12 would give me 17.5. So recap what I'm showing you with this one right here. At face value, we have an ability, based on what we did on our quiz, to set this up, and we could actually go find x. But here's the cool part, is that with this, where the other figure, let me scroll back to it real quick. Where this figure right here, you notice these two sides right here did not have those little triangles present, where this one does. Well, where this one does. So if you recall, the little triangles means that they are parallel lines. And when we start throwing parallel lines into the mix, there's some interesting relationships that take place. For instance, some things that we talked about in class the other day is that how like these two parallel lines right here going on forever and ever is being cut by a transversal, which means that this angle and this angle are congruent. This one and this one's congruent. Both triangles are shared. So there's a lot of so what that tells, there's a lot of relationships. So what that tells me is that I can actually look at this right here, and I can say, okay, wait a minute. These right here, so this side right here and this side are going to be in proportion to each other and set equal to these sides. So I can look, whenever I see a triangle like this with parallel lines, I can actually make a proportion a little bit faster and cleaner. So let me show it to you this way. I'm going to erase everything except the fact that our answer we know to be 17.5. I'll just move that over here to the side so that we remember. I can actually set the 12 over the 14 and the x, I'm sorry, not x, the 15 over the x. So now, notice how I made sure if I started here and here, I followed the same format right there. So if I go through, say 12 times x, 12x, 14 times the 15 is 210. So take 210 divided by 12, and I have 17.5. Same thing. Now, you've got to remember that this is a interesting and a very special situation. It's when I have two parallel lines like this. This doesn't work on like that problem I showed you on the quiz a second ago. So let's take a note or two up here at the top. So some things to draw out of this and come away with. So with this figure here, if DE is parallel to AC, if DE is parallel to AC, then I can make a proportion with this. I can say, okay, BD over AD equals BE over EC. Okay? So, while we're at it, the converse to this. So, if you remember, converse is where I take the if-then statement and just rewrite it. So, the converse of this would be if I can prove that these two ratios are in proportion. So, if my two ratios are proportional, then I can conclude that these two lines are parallel. Okay, so I'm gonna work a couple more out with you here, and then I'll let you go from there. So with number 3, I'll do this one. So this time, now like I said, you could always go back to the traditional route with these, but this one can be done a little bit faster. So this piece right here, I don't know what it is, but I do know that the whole length is 55, and I know this bottom part, this part is 45. So if I just take 55, subtract 45 from it, you find out that that is a difference. Hang on, let me erase that right there. You find out that that is a difference of 10. Okay? So now I can set my proportion up. X over 36 equals, so x over 36 equals 10 over 45. So that's 45x equals 360. So that should be 8. So 490 and 436. So yeah, 8. So divide by the 45. And x equals 8. So let me make sure. You know what? Let me try and move over here. That way I won't be as much in the way. So there you go. The big idea with these is small, like each side. Basically, you can think of it as almost like that line is the fraction bar, like 10 over 45, x over 36. One word of caution with this would be, if you start here, x over 36, do not say 45 over 10. You know, that's like going here to here, here to here. So be careful about that. I don't want you to miss something simple. If you flip over to the back side of this page, there it is, proportional parts and parallel lines. So this follows right along with the stuff that we were just doing, except that this time, instead of there being like 2 parallel lines, there's 3. Truthfully, there could be 4. There could be 5. I mean, infinite, really. But so with proportional parts and parallel lines, so here's my statement. If So if AB, line AB, is parallel to line CD and is parallel to line EF. If I can prove, or if they tell me those are parallel to each other, then I can conclude that AC over CE equals BD over DF. And I'm going to zoom that in a little bit to make sure you can see that well. That's one of y'all's complaints, is that y'all couldn't hear and you couldn't see very well on the things last time. So make sure we're getting that. So that's your statements. Okay, so let's just jump right in and try a couple of these, and then I'll turn you loose. So with this one, what that's saying is, so they're telling me that these three lines are parallel. So what that means is I can set a proportion up, say like 45 over 18, equals the 52 over the x. And from there, cross product. So you get 45x equals 936 and divided by 45. X gives you 20.8. I'll hold there just for a second. Okay. So let's do one of them that maybe has a little more veiled. So let's look at this number 13. So number 13, this is kind of like one of the second ones I did on the front page. They're telling me, okay, all three are parallel. The whole thing's 92, so if I want to figure out this length, just take 92 and take that 28 off of it. So that'd be, what, 64? Okay, so again, they've proven, they're telling me those are parallel. So I can say, all right, 28 over 64 equals 31.5 over x. So when I go through and multiply this, the cross product, got 28x equals 64 and 31 and a half. It's 2016. So divide by 28. And x is 72. So that, with these two theorems, that's really pretty much it. It's just a continuation of what we've been doing. Just a special relationship. You don't have to necessarily go through like, okay, x over x plus 31.5 and set equal to 64 over 9. You don't have to do that. You can do this a lot more efficiently. So key things is parallel lines, and you can set these over each other and solve very quickly. So your sub will have your assignment, which one of your assignments will be to finish the problems on this page that I didn't do, and then a little homework assignment to correspond to this. So I'm going to stop the video here. Y'all get after it.